In this video, we will learn how to balance redox reactions. Before you watch this video, I would recommend that you first watch my video on how to identify redox reactions, as it will provide you with the relevant background. So before we start balancing this equation, we need to calculate the oxidation numbers of the main elements present. These main elements include iron and manganese. So let's start with iron. As it's a monatomic ion, the oxidation number of iron is the charge present on iron, which is +2. And after the reaction, the oxidation number of iron is +3. Now let's calculate the oxidation number of manganese together. If you have watched the previous videos, you can skip this part, as you would already know how to do this. So we don't know the oxidation number, it's X. We know that there are 4 oxygens present in this compound, and the oxidation number of oxygen is -2. From the first video in this series, we also know that the sum of the oxidation numbers of all the elements that are present within a polyatomic ion is equal to the charge on that ion. So in this case, the sum of these oxidation numbers is equal to -1. Now that we have an equation, we can solve for x. So x stays on the left side. 4 times 2 is -8. -8 goes to the other side, becomes positive. 8 minus 1 is 7. So +7 is the oxidation number of manganese in this reaction. And after the reaction, the oxidation number of manganese is +2. We have calculated the oxidation states of all of the elements present. We can reduce this overall redox reaction to its corresponding reduction and oxidation half reactions. So reduction is characterized by a decrease in the oxidation number. We see that the oxidation number of manganese decreases from +7 to +2. So this represents the reduction half reaction. Let's write this down. So before the reaction, we have MnO4 minus, and after the reaction, we have Mn2 plus. It's present as a monatomic ion. So now you would see that this equation is not balanced either by charges or by the elements present, oxygen, but we will come to that later. Let's write the oxidation half reaction too. So oxidation is characterized by an increase in oxidation number, and the oxidation number of iron increases from +2 to +3. So this is the oxidation half reaction. So we have, to start with, we have Fe2 plus, and after the reaction, we have Fe3 plus. Now that we have written the skeleton for the half reactions, we will start balancing out the equations. So we balance our redox reactions in this order. First of all, we balance all the elements present. Now the elements in these half equations are already balanced. We have 1 manganese atom on both sides, and we have 1 iron on both sides, so that is not a problem. Once we have balanced them, we balance the oxygens on each side by adding in H2O. We notice so we will need to add H2O onto this side to balance this equation. Once oxygen is balanced, we balance the equation by adding in hydrogen. And we balance the hydrogens by adding in the hydrogen ions. And after the hydrogens have been balanced, we balance the charges on both sides of the equations by adding in electrons. So let's start with manganese. The element manganese is balanced on both sides. We only have 1. To balance oxygen, we will add water to this side. So we will add H2O. Now you would notice that we have 4 oxygens on this side. So to balance it, we will need to have 4 on this side, 4 oxygens. But now we have hydrogens. Now that the oxygens are balanced, the next step is to balance the hydrogens. We have 4 times 2, 8 hydrogens on this side, and we balance the hydrogens by adding in the hydrogen ion. And there are 8 hydrogens, so we write an 8 in front. Now that all the elements are balanced, we balance the charges. So the charges on both should equal on both sides of the equation. So if the charge on this side is +2, the charge on this side should also equal +2. Let's calculate the charge on this side. So the total charge on this side, we have 8 plus 8, and we have 1 minus. 8 minus 1 is 7. So the total charge on this side is 7, and the total charge on this side is 2. So in order to balance the charges, we add 5 electrons on this side. Electrons have a negative charge. 7 minus 5 is 2. So the charge after adding in the 5 electrons is balanced. Now we will move on to the oxidation half reaction to balance that reaction. So the elements are balanced. There are no oxygen or hydrogen present to balance, but we still need to, the next one are the electrons. We still need to balance the charges by adding in electrons. There are 2 positive charges on this side and 3 positive charges on this side. So we add 1 electron on this side so the charge on both sides of the equation is equal. 3 minus 1 is 2. So the charge on this side is 2 and the charge on this side is 2. But we are not done yet. Until now, we have only balanced the half reactions. Now we need to write down the overall redox reaction. So how do we balance that? We simply do that by balancing the number of electrons that are present in both these equations. So in the reduction half reaction, we have 5 electrons, and the oxidation half reaction, we have 1 electron. The number of electrons in both these equations should equal, so we can balance it, so the charge will be balanced. So we multiply the second equation, the oxidation half reaction, by 5. So 5 times 1 is 5, that would equal 5 electrons. And once we have done that, we write the overall equation down. So we split this into half. So first of all, we will write all the components present on the left hand side. Let's start with MnO4 minus. So what else do we have on the left hand side? We have the iron Fe2 plus, and we have the hydrogen ions. We will write them down, and we have 5 electrons on this side of the equation. Now we'll move on to the right hand side. On the right hand side, we have a manganese ion, an iron ion with 3 charges, and we have 4 H2O. Also have 5 electrons on this side of the equation. So 1 times 5 is 5 electrons on this side of the equation. Now that we have written the overall equation, we can simplify it further by cancelling the components that are present on both sides of the equation. So we have 5 electrons on this side and 5 on this side. This can be cancelled. As we can also cancel the number of hydrogen or water molecules if they are present on both sides, but in this case they are not, so we can't do that. So this is how we balance redox reactions. This is the overall balanced equation for this reaction. Please make sure that once you have written the overall equation, you cancel out the components that are present on both sides of the equation. Hope you have understood this. If you have any questions or require more examples, please leave comments in the comment section and I will try my best to get to them. Thank you for watching this.